enjoy a conversation with you. So I will keep my comments brief. I know we want to really spend most of the time in discussion and so forth. So yeah, I just want to say, by the way, thank you to Nell Whiteway before I kick off, because Nell worked with us for 3.5 years at the Faraday Institute and actually did a lot of research which gave the background to material that I was using in the Gifford lectures. So really she was a great asset, and I just wanted to thank her. She headed from, by the way, from the Faraday Institute, she headed out to Madagascar to work on the Mercy ships, that's right, for 6 months. And just going back there for another 5 weeks apparently. I just learned that today, so thanks to Nell. The sort of background that really got my interest going was this kind of quote, which was in a review in Nature a few years ago, which is quoted actually in the paper in front of you, is the sense that you get from some scientists that really the old days, the old bad days of genetic determinism, which we all thought in biology are long dead and buried, are actually not really long dead and buried, and they keep sort of coming round again, you know, at different times. And here's this quote from John Hidding, who's actually not a geneticist, but he writes, an increasing number of studies suggest that biology can exert a significant influence on political beliefs and behaviors. Genes could exert a pull on attitudes concerning topics such as abortion, immigration, the death penalty, and pacifism. It's difficult to change someone's mind about political issues because their actions are rooted in their physiology. I mean, I don't know how that got into a Nature overall review, but it did. And those sort of comments are not totally uncommon in a certain segment of the scientific literature. So I think it's a kind of new form of genetic determinism, not like the old form. It's not really hard, you know, determinism in the old horrible form historically, but it's a kind of more insidious backdoor kind of determinism that comes in through these sorts of comments where people feel, you know, there's a gene for this, that, and the other. Here's some examples. Gluttony gene, gangster gene, mean genes, cigarette genes, whatever you want. I like this one down the bottom right hand side. The geneticism gene is there, a gene that predisposes some people to think the behavior is determined. This was in The Guardian some years ago. That's my favourite. But you know, this, you've got this sense that it's in my DNA, it's in the organisation's DNA. I hope the Jubilee Centre never says this something is in our DNA as an organisation. That phrase should be banned, okay? Because again, it sort of gives a kind of impression, you know, that really things come down to somehow the DNA in our bodies and so forth. So that's the background. That's how I sort of got interested in writing about this kind of stuff, to really try and address it. Because there's a lot at stake here, isn't there? Free will is at stake, justice is at stake, you know, responsibility for people's actions. A lot of, we live in a blame culture, you know, there's such a tendency for everyone to blame everybody else for what they've done, but they want to pass on the blame to somebody else. Relationships, obviously, I mean, free will is terribly central to relationships. If love in some way in our personal relationships is not within our power to exert and to exercise and practice, then what does it mean? You know? So it's very, very fundamental to our own lives and to society more broadly. I'm sure you know that the person who got the sort of nature and nurture language going is Francis Galton, who was the first cousin of Charles Darwin. He talked about that phrase being a convenient jingle of words, and he was absolutely right, you know, dead right. You still get lots of books coming out using the phrase nature and nurture. Galton himself, he did recognize the influence and power of the environment, but to be honest, well, that quote there in a sort of rather Victorian language is rather typical of Galton. No carefulness of nurture can overcome the evil tendencies of an intrinsically bad physique, weak brain, or brutal disposition. I think that's a very Victorian sort of way of looking at things. But I think he sort of set the scene, really, for the 20th century. How was this discussion going to be carried out? And it's been carried out, but this is the framing of the discussion, if you look back over the 20th century. And so, obviously, more recently, we've come to use more the language of genes and environment, and there are other, you know, phrases. What we notice about these sort of phrases, they're all dichotomous. You've got the genes over here, you've got the environment. And often the impression is given that somehow they're almost like in warfare with each other, in conflict. They're kind of competing, you know, for their hegemony over the human individual or any living organism's way of being and so forth. But we're talking here particularly about humans. So what I've done actually in the paper is to come up with this really mouthful of an acronym which I call it dicey, okay? And the reason of having this acronym is to simply give us 4 words that act as pegs upon which to hang 4 really key ideas, which takes us, I think, away from dichotomous language. You'll find this, I think it's in the paper somewhere. Developmental integrated complementary interactionism, okay, big mouthful. But simply meaning that the key to understanding human personhood from a biological perspective, many perspectives, is developmental. From the word go, how do we develop it? The development carries on all the way through life. Everything's integrated together. There are many complementary narratives that you can tell about the development of the human individual, biological narratives, psychological narratives, environmental narratives, and so on. You can stack them up, lots of narratives, and we need them all, and they're all integrated together. And we, of course, have a hard time as scientists, and indeed social scientists and so forth, we have a hard time in keeping these narratives in balance. There's always a tendency for one narrative to say, this is the one that really matters, when it's just one of many. This is simply a way of illustrating that point. If you look from the fertilized egg, a bunch of cells called the zygote, and then newly fertilized egg called zygote, and then blastocyst, and all the way up to, here we are at the top, as it were. Yeah, that's me. So, with my grey hair, which is all, of course, determined. I didn't choose it. Anyway. So you've got your macro environments, you've got your micro environment. Macro environment, all those big sort of things from the beginning, even things like what you get in your placenta and what your mother's eating at the time when you're in fetal development and so forth, then all the way through that key part of development, our brain growth and so forth. First couple of years, very critical, where synaptic density is increasing and so forth, and it's very dependent on environmental inputs all the way through to the choices made today. And then you've got all your microenvironments, if you can see them, but all those things inside the cell and the regulation of the DNA and the genome and all that kind of stuff, that's critically important, and it's all talking to each other, it's all in interaction. So that sort of illustrates dicey, really. Everything's interacting, and it's you've got many complementary narratives going on there. So what I'm really trying to do in the paper is get away from dichotomous language. I just think it's unhelpful. Yes. I think it's out of date. I think it's not reflecting where contemporary biology is. And by the way, it's not theologically helpful either. Okay, that helps. Okay, so what I want to say in the paper is that 100% of our phenotype, that is to say, phenotype, what we are as beings and all our being, our psychology, our obviously our biology and everything, 100% of it involves genetics, 100% involves the environment. Okay, both end. Okay. So then we come up with this sort of illustration. For those who don't like science very much, we have our Black Forest cake, and we think about how you cook a cake, and you think about all the ingredients, and you think about how you develop that in the oven in the right temperature, in the right environment, and out comes a cake. Okay, could you go back to the components of the cake? No, you cannot go back. It's a one-way street. Okay, that's what development's about. Okay, and so in a way, the cake is an emergent phenomenon. You can't reduce that cake to its constituents. Some of them are no longer in the cake. Baking powder's gone. Okay, you need baking powder to make it rise and so forth, and that's chemically transformed, and as are a number of the other components. And I think that's more the way to think about us as biological beings, that we are that developmental process product. Behavioral genetics is a huge topic. I'm sure we would like to discuss a bit about that. We actually vary amongst ourselves genetically more than we had realized even a few years ago. Something like around about average 0.5% probably of our genomes between us in this room are different in some small respects. Okay. Some of 0.1% of that variation are these single nucleotide polymorphisms. That means one single genetic letter is different. Okay, so about 1 out of 1,000 of all our genetic letters in our whole genome are different in this room on average. Okay, so that's quite a lot of difference. Big study in Iceland a few years ago now revealed that every newborn has about 60 new mutations on average, which is more than people had realized actually. So you've got all this variation. So behavioral genetics wants to find out methods, to find out how that, what impact does that have on behavior, differential behavior between individuals. Okay, and this is the way it's done. It's a bit technical. You can just zip through it to give you a little flavor, but The whole idea is to use twin studies, identical twins, non-identical twins, adoption situations, twins raised apart, all that kind of stuff. And to work out the contribution of the genes in relation to the contribution of what's called the shared or the non-shared environment. And so the idea is to separate out, measure them separately somehow. A trait in this context can be anything you can measure. Number of hours watching television, how many times you come to the lounge every week, not. That's sexual orientation, personality, I get whatever you like. If you can measure it, that's a trait, okay, in this context. The shared or common environment then are things like parental style, socioeconomic status, your diet, those are common. Non-shared, unique environmental influences would be just one-off events that happened to you. Maybe you got bullied at school, your twin didn't get bullied or something like that. How much alcohol do you drink, do you take drugs, and so forth. These sort of things that are unique to you really would be the non-shared. And so the aim of this so-called heritability study is to try and then calculate this proportion of the variance in the trait, how much they vary in a population, that you can ascribe to genetic variation. Okay, that's very careful to get that. It's not inheritance. We're not talking here about inheritance, we're talking about heritability. That's a population study. It's not the percentage of your IQ you get from parents. That's not what heritability is about. Heritability is about the variation in a population. And using these sort of twin studies, how much of that can you ascribe to genetic variation in that population? Two very important points. It's very slippery. It used to mean, the word heritability used to just mean inheritance. It used to be just a synonym for inheritance. It's still used in that sort of way. Now it's got this technical second meaning that I just mentioned. And it often slides from one meaning to another in the same book, same passage, same chapter. Confusingly. Really confuses journalists, I have to say. Here's a simple illustration. Some people have only one leg. Nearly always, it's not always, but nearly always it's due to an accident. So the variation in the legginess in the population is therefore 100% environmental and 0% heritable. Okay, that's just an illustration. Which sounds a bit weird because we all know genes have something to do with legs. We have during development, but it's about variation. That's the key thing to remember. The other thing is, I think we won't get into maths, but it's not very helpful in the sense that it's a mathematical construct, heritability. It's a statistical construct, okay? It's about variation. But people jump very quickly to the idea that they reify it, they sort of give it as if it had a biological meaning, which it doesn't have, not directly anyway. And so, so it tends to support, keep going this dichotomous language, which is so unhelpful, and that's a problem. Are we slaves to our genes? There is no gene for any particular behavior. We can be clear about that. I've already said, in my view, 100% of what we are is genetic, 100% is environmental. I love this verse from Psalm 139:13. Created my inmost being, you knit me together in my mother's womb. Now I know the psalmist didn't really have developmental biology in his mind writing this, but it's that idea actually of knitting, we're sort of knit together. When you look at the product of knitting, it's all woven together, which is rather wonderful. So if genes don't cause behaviors, which they don't, clearly specific gene variants cause differences in the trait, and that's the key thing. So they do predispose, yes. They do cause differences. Here's a difference they can cause. Get a very tall person who likes playing basketball. These two guys, I can't remember their names, are from the same American basketball team. Maybe somebody here in the States can tell me what that says. Bullet? I don't know. Anyway, lots of short people choose not to play basketball, but some do. So if you're tall, it gives you probably a predisposition. You're more likely to play basketball because you're rather good at it. But you still have to make a choice. That's the sort of where we're going with this sort of idea. So genetic differences are difference makers. Before I finish, a couple of words on the conversation with theology. I've chosen in the paper to go through the route of making the imago Dei, the image of God, as a bridge, if you like, which can help us in our discussion between genetics and theology. And there are many, many parts of that bridge. There are many ways across that bridge, if you like, in terms of conversation. Two I'm just going to flag up as I finish. First of all, I think it's incredibly important that the image of God, which refers to the whole of humankind, gives a value and a status to that individual that is independent of their genetic capabilities, their genetic background. And particularly now, I think, where we have an increasing ability to change the human genome, at least in principle. It's not legal to do that, but in a way that will be passed on to the next generation. That issue is terribly important. But we don't have second-class citizens who are somehow, genetically disabled in some way or something like that. The image of God is a wonderful preserver of the value of the human individual, and it subverts any attempt to make these distinctions between individuals based on their genetic endowment. And then I think also this very powerful entailment of our responsibility that we have coming through in the early chapters of Genesis, that Adam and Eve are given a choice, they're given a responsibility, they're given, and so forth. That whole sense of choice and free will, which is a huge discussion in itself, obviously, it is a very big issue, and I think that has to be central to this discussion as well. So, conclusion, I don't think myself there's anything in contemporary genetics except for severe pathology. There are severe genetic pathologies, let's be clear obviously about that. Apart from those, I don't think there's anything in contemporary genetics that subverts personal moral responsibility. I try to emphasize genes don't control us, they don't sort of subvert our moral responsibility in any way, and so forth. They're integrated with all we are as human beings. There are no genes for particular traits like gluttony or whatever it is. And so the conclusion is we simply cannot escape our responsibility to God, to the environment, and indeed to our own environments around, and we're going to be called to account. So that's the bottom line. And thank you very much for listening, and this is the shameless plug, of course. Oops. At the end. I always have it in there. Okay.